acquisition. There are three basic stages to this project. The first stage being signal acquisition using EMG electrodes, as you can see over here. The second stage being a signal acquisition circuit, which is used to acquire and process the signals. That is seen over here. Then you have a microprocessor, which is used to process the signals that have been acquired. And the last stage, you have an analog servo, which is used to drive a finger replacement. The EMG signal acquisition circuit, which is the heart of the entire apparatus. You can see here, this is what we've made. The EMG signal acquisition circuit has four basic stages. The first stage being an instrumentation amplifier. The second stage, a precision full wave rectifier. Third stage, an integrator. And the fourth stage, an amplifier. Coming to the first stage. The first stage is an instrumentation amplifier. The make is INA114AB, which is manufactured by Texas Instruments India. And the inputs to this instrumentation amplifier are in the form of mid and end muscle activity signals through the electrodes. And you have one electrode which is placed at the bony part of the elbow so that it acts as a reference. We also have a DC blocking offset capacitor. The second stage, which is a precision full wave rectifier. Why do we use a precision full wave rectifier? A conventional rectifier is unable to process signals which are of very low voltage. Since we are dealing with voltages as low as 2 to 5 millivolts, we use a precision full wave rectifier. The third stage is an integrator. The integrator is used to process the signal in such a way that we get a smooth wave from the precision rectified output. The make is the TIIC IADC, which is made by Texas Instruments. The last stage, being the amplifier, does its native job of simply amplifying the circuit. In this case, we also use the TIIC, which is manufactured at Texas Instruments. This specific chart shows us where the particular muscle activity can be measured. In our case, we are using the points which are highlighted over here. This particular one shows the signals throughout the process. At first, at the muscles, we get the raw data, which is nothing but a lifting exercise. At the end of the instrumentation amplifier, we get a DC offset removed, which is removed using the DC blocking capacitor. After the rectified output, we get a rectified EMG signal. A low pass filtering is done in the case, and at the last stage, we have an integrated effort motion.
We shall now take a look at what core components and circuits drive the entire setup. Firstly, we have EMG surface electrodes, which are used to detect the myoelectric activity present in the muscles that are used to drive the fingers. These electrical activity is transferred through these electrode cables to the EMG signal acquisition circuit as discussed before. You can also have a look at the internal circuitry. We have used an MSP 430 with a G2553 chip in order to provide the processing power for the setup. This is used to drive two analog nano servos, to ends of which we have attached two finger-like objects. The entire setup is then powered by three 9-volt batteries. The entire setup is made quite portable, as you can see.
നിർത്താം.